Well, welcome back everyone, and this is actually the 100th video that I've made for the flipped classroom project that I've been doing, so I hope that they've been useful so far. In this example, we're going to look at calculating interference, and what we have are two speakers that are separated by some distance that we're going to call x, which we don't know. And we know that there's some guy standing here, and that this distance is actually about 12.0 meters. And what we want to know is what's the smallest distance apart. I think what I'll do is I'll move my guy down here so it's more to scale. What is the smallest distance apart, x, that I can make these two speakers and get destructive interference? Well, in order to have destructive interference, we need to make sure that whatever wave comes from one source is out of phase by the other wave that comes from the other source. And so if one of them is a crest, we need the other to be a trough. Okay, so that's how we get something like this. They're going to cancel out because if I superimpose them, one of them will go up and come down and the other one will do the opposite. Okay? Now, if this is 12 meters right here, then this distance right here is going to be the square root of 12 squared plus x squared. But there's another thing that we can do. We basically want the extra distance that the second wave travels, or the hypotenuse, we want that extra path difference to be at least half a wavelength. That's the only way that we can get it to interfere constructively. So you can see that wave number 1, wave number 2 are off by exactly a half wavelength. And you can see that if I were to continue them. Okay, so that means that we need to take the information given, that the frequency is 1,000 hertz, and that the speed of sound in this problem is 340 meters per second. And we need to calculate what the wavelength actually is if we want half a wavelength difference. So we remember V is equal to F lambda, so lambda is V over F, and that's 0.340 meters. So half of that, the path difference is 0.17 meters. So this actually makes it pretty easy. We want this to be equal to 0.17. Oops, I'm sorry. We don't want the hypotenuse to be 0.17. We want the difference between the hypotenuse and the leg to be exactly 0.17. So in other words, the wave that starts over here on the right and goes to the person standing here must be 1/2 wavelength off of the wave that comes from the left. Okay, so now this just becomes a simple algebra problem, and you get something like this. Oh, sorry, made a bit of a boo-boo. This is actually just 12. Okay, so 12.17 is the square root of 12 squared plus x squared. And this gives us a value of x is equal to 2.03 meters. Okay, and that solves it. This, by the way, is problem number 76 on page 502. All right, so we'll see you next time.